Hi everyone. In this lecture, we will continue our session on separable equations and we will do some more problems in solving separable equations. We have seen that an equation is said to be, an ordinary differential equation is said to be separable if we can separate the variables on into two sides of equation. That is, we can bring all the independent variables to one side of the equal to and all the dependent variable to other side of the equal to side. Such equations are called separable equations, and this separable equations can be used to solve some kind of first order ordinary differential equations. We will see some more problems on this. Here the equation given is x raised to 5 into y dash plus y raised to 5 equal to 0. First of all, we will write y dash as dy by dx. So this y dash is written as dy by dx. Now we have to try to separate the variables y and x. That is, we have to bring y, all the terms in y to one side of equal sign and all the terms in x to other side of equal sign. For that, first we will bring this plus y raised to 5 to right hand side and it will become minus y raised to 5. Now we will take this x raised to 5 and dx to right hand side and y raised to 5 to left hand side, and we get dy by y raised to 5 equal to minus dx by x raised to 5. Now we have separated the variables. That is, all the terms in y are in the left hand side and all the terms in x are in the right hand side. Once we have separated the variables, we will integrate both sides. Integrating both sides, we get integral dy by y raised to 5 equal to minus integral dx by x raised to 5. Now we have to do the integration. For that, 1 by y raised to 5 will be written as y raised to minus 5. Similarly, 1 by x raised to 5 will be written as x raised to minus 5. And we know that integral of x raised to n is x raised to n plus 1 by n plus 1. So, integral of y raised to minus 5 will be y raised to minus 5 plus 1 by minus 5 plus 1. And integral of x raised to minus 5 will be x raised to minus 5 plus 1 by minus 5 plus 1. Simplifying, we get y raised to minus 4 by minus 4 equal to minus x raised to minus 4 by minus 4 plus we have to put the constant of integration c. Again, on further simplification, we can multiply this equation throughout with minus 4 so that we can cancel this by minus 4. And we get y raised to minus 4 equal to minus x raised to minus 4 minus 4c. It can be written as 1 by y raised to 4 equal to minus 1 by x raised to 4 plus this minus 4c is again a constant which can be taken as capital C. So, minus 4c can be written as plus capital C. So, this is the final answer. Now, we will see another problem. The question is xy dash equal to 1 minus 4x square tan y. First of all, we will write y dash as dy by dx. Now, we will try to separate the variables. That is, we will bring all terms in y to one side of equal to and all the terms in x to other side of equal side. For that, we will take x and this dx to right hand side and tan y to the left hand side. So, we get dy by tan y equal to 1 minus 4x square by x dx. 1 by tan y is cot y and this can be simplified as 1 by x minus 4x. So, now we have separated the variables. Once we have separated the variables, we have to integrate both sides. So, integrating both sides, integral of cot y is log sin y, integral of 1 by x is log x, integral of x is x square by 2. So, we get log sin y equal to log x minus 2x square plus the constant of integration c. We can stop here, but if we want the answer as y equal to a function of x, we can do further simplification. That is, we can take e raised to on both sides So here when we take e raised to, e and log are inverse functions, they will get cancelled and we get sin y equal to e raised to log x minus 2x square plus c. Now we can split this side, that is e raised to log x into e raised to minus 2x square into e raised to c. Again, in e raised to log x, e and log are inverse functions and will get cancelled each other and we will get x. So this becomes x into e raised to minus 2x square into e raised to c. Again, e raised to c is yet another constant which can be denoted as capital C. So the equation, so this becomes cx e raised to minus 2x square. Now we can bring this sign to the right hand side. It will become sine inverse and we get y equal to sine inverse of cx e raised to minus 2x square. This is the final answer. Next is an example of an initial value problem. Initial value problem means along with the ordinary differential equation, we will be given some initial values for x and y. That is, we will be given some values of x and y so that we can calculate the arbitrary constant of integration in that solution. So here the question is y dash equal to x plus 1, y of 1 equal to 3. This is the initial condition. This means when x equal to 1, y equal to 3. That is, when the value of x is 1, the value of y will become 3. That is the initial condition. Usually this initial condition will be used to find the value of the constant of integration. So first we will solve the ordinary differential equation given. In that solution we will be having an arbitrary constant of integration. Then we will use the initial values to find the value of that arbitrary constant of integration. So first we will consider this ordinary differential equation y dash equal to x plus 1. First of all we will write y dash as dy by dx. So we get y dy by dx equal to x plus 1. Now we will try to separate the variables. For that we will bring dx to right hand side and we get y dy equal to x plus 1 dx. Once we have separated the variables, we will integrate both sides. Integrating both sides, we know that integral of y is y square by 2, integral of x is x square by 2 and integral of 1 is x. Plus we have the constant of integration c. Now this is the solution. Now we have to find the value of this constant of integration c by using the initial conditions. For that, in this solution, we will substitute this initial condition. That is, we will substitute y equal to 3 and x equal to 1. So here we will give y the value 3 and x the value 1. So we will get 3 square by 2 equal to 1 square by 2 plus 1 plus c. Simplifying this, we will get the value of c as 3. Now this value will be substituted in this solution. And so the particular solution is the solution that is obtained after using initial condition is called particular solution. So the particular solution is y square by 2 equal to x square by 2 plus x plus 3. Thank you.